Hello, good afternoon. Can you hear me? Okay. So shall we start the lab? Okay. So I will share the screen with you people and we'll discuss the practical what we have to do this week. Okay. So I'll share the screen. Just a moment. So today we will be discussing as to calculation of the heat load for the design of the AC system. Okay, so calculation of 1 minute. E tab 6. So experiment number 6. Aim is calculation of heat load for AC system design of vehicle. So as you all know that for AC system design, since you have studied the refrigeration and air conditioning, you require the heat load which has to be known before the design of the vehicle. So for the or it is called as the cooling load calculation as well. So I will write down the theory what we have to do actually. So here I'm not going to give you any specific kind of the you can say dimensions or formula. Rather, I will share some literature with you. Based on that literature, you will have to design. But I will explain you the basic heat received from the heat sources for automobile space. कौन से हैं? Okay. So the first is heat sources for automobile. For automobile space, what are they? The heat sources. The first one is heat flow from exterior walls, including solar radiation. So heat flow from exterior walls. This including solar radiation. Including solar radiation. So the formula, and please note that for calculation of the heat load, we assume the steady state condition. We are not assuming any transient, because in transient, then that analysis will become further complicated. So you will say that this Q1 is denoted by heat flow from the exterior. So Q1 is equals to U into A into T0 minus Ti, where T0 is outside temperature, T0 is outside temperature, Ti is basically the inside air temperature. Inside air temperature. Please understand that whatever we are discussing will be valid for your automobile theory as well, class as well. So inside air temperature, A is the total area through which heat is being transferred. It is the total area through which heat is being transferred. U is the overall heat transfer coefficient. Overall heat transfer coefficient, and this is equal to 1 by HO, sorry, 1 by U is equal to 1 by HO plus x1 by k1 plus x2 by k2 plus so on plus 1 by H1. So heat transfer coefficient, or HI. So this is basically HO and HI is heat transfer coefficient of outside and inside surface of the vehicle. So this will be required for you. Now where just wait, we'll write down and we'll discuss here. X1 and X2 is the thickness of the sheet metal and insulation respectively. So X1 and X2 is the thickness of sheet metal and insulation. Then K1 and K2 are the thermal conductivity of sheet metal and insulation. Thermal conductivity of sheet metal and insulation. Okay. Now the second one is, please note that for these things, HO and HI, I will be sharing one research paper so that you can read those research papers. There are some empirical relationships which is given. It will give you an idea that how to calculate the heat load from that particular research paper, because if you refer to any book, these are the only formulas which are given. So you can assume for your kind of vehicle whatever the value that correlationships in that particular research papers are given, so you can calculate that. Then heat generated due to passenger present in car. So heat generated due to passengers present in the car. This is given as Q2. More or less, this Q2 is equal to 334.4 kilojoule per hour. This is basically the average value. So you can multiply and you can get the value that what is this is per person. If the average value considered that human body is considered as an engine which converts thermal energy into mechanical work with a thermal efficiency of 20%. Okay. So this is the average value you can take. Then the third one is heat liberated from equipment. Heat liberated from equipment. That means whatever equipment they are fitted in the car. So electrical appliances and other things. So it is taken as the Q3. This is equal to the kilowatt specification of that particular equipment multiplied by 860 multiplied by use factor. So this will give you value in uh, kilojoule per hour. So how to calculate this use factor? So this use factor is equals to actual wattage in use, actual wattage in use divided by install wattage. This use factor is, let us say you have got 1, 2, 3, 4, 5 equipments which are installed in the vehicle, but out of that you are using one. So actual wattage in use, that you will put it here and install wattage. So for example, you can have fan and other thing, so that you can use it. So this is basically the thing. This is very negligible compared to other things, so please do not worry. Even if you neglect it, there is not going to be much difference, even if you are using, you neglected this. Then the heat received from infiltrated air. Then the fourth one is heat received from infiltrated air. So this, you can say that this is your 5. This 4 is, there is an example that the Q4 is basically heat due to fan. So that is basically the Q4 is equals to the kilowatt of the fan divided by the mechanical efficiency. So this is Q4, heat due to fan. Now this Q5, so Q5 comes out to be W, that is the weight of the air infiltrated per hour. So W into H suffix D minus H suffix B. So here your W is weight of air, rather it should be mass of air infiltrated per hour. This is not the weight, this has to be mass. And HD is the enthalpy of air at dry bulb temperature. HD is enthalpy of air at dry bulb temperature, and HB is enthalpy of air at wet bulb bulb temperature. So now you have got 1, 2, 3, 4, 5. So total heat load has to be the addition of all these. So you can say that the total heat load is equals to Qt will be Q1 plus Q2 plus Q3 plus Q4 if there is a fan plus Q5. So you can have the appropriate apparatus if they are in use, then you can put it here. Then for passenger, you need to compare the what is the you can say number of occupants in the car. Here, please note that the general data is amount of air infiltration is taken as 4 meter cube per hour. Basically this 4 meter cube per hour per meter of crack. That means whatever opening is there, so you take the length of that if there is a crack. So that is basically the amount of infiltration you have to take this as the average value. So not to worry. Now, if you then the thermodynamic cycle, this will be required for you for calculation of the power required for compressor. I will just draw the diagram to give you the expression. I'm giving you the general idea, then specific thing you can get it from the research paper. तो आप अपने व्हीकल के लिए ये कैलकुलेशन कर सकते हो, ऐसे कोई डिफिकल्ट चीज नहीं है. Here it is, it has to be enthalpy, sorry, enthalpy, and here it is temperature. So this is the diagram of a cycle. Then you may have like this. So depends कि आप कितना सुपर हीट इसको करते हैं या फिर ये पोजीशन है या इतने इसमें ही आप ऑपरेट करते हो. तो दिस इज पॉइंट नंबर 1, 2, 3, 4. This is 1 double dash, this is 2 double dash, this is 1 dash, this is 2 dash. Okay, so now process 1 to 2. 1 to 2 is the compression. From 1 to 2 is compression. Then 2 to 3, it is heat rejection. 2 to 3, if you move from here, 2 to 3, heat rejection in condenser. So heat rejection is given as, I am writing down the general expression, H2 minus H3. So for compression, this compression is equals to H2 minus H1. Okay, because this is required, the process is required because we wanted to know that how to calculate the power required, the overall process one should know. So this is basically the cycle, refrigeration cycle. Then 3 to 4, then 3 to 4 is the expansion. And 4 to 1 it is basically the process of coolant latent heat of vaporization. So heat absorption in the evaporator. It is heat absorption in evaporator. So this is given as heat absorption is, this is H1 minus H4. So this is basically the process of the or the thermodynamic cycle. Now you know that the how to calculate the various parameters is COP कैसे निकालेंगे, रेफ्रिजरेशन इफेक्ट, divided by compressor work. This is equals to refrigeration effect is H1 minus H4, H1 minus H4 divided by compressor work. We have just written here, it is H2 minus H1. This is COP. Then mass of refrigeration refrigerators, mass of refrigerant. This is equal to total heat load. Here you will require the total heat load. Total heat load divided by refrigeration effect. So this comes out to be total heat load is Q total divided by refrigeration effect is H1 minus H4. Okay. Then the power required, piston displacement of compressor, that we don't know. Then last one is power required. Power required will be compressor work divided by mechanical efficiency of compressor. Okay. So N is mechanical efficiency of compressor. Please note that this is the general procedure for calculation of the total capacity of the compressor. See, finally, the AC system design is what we need to calculate the capacity or the power required for the compressor. Please note that here we have to draw the layout as well, layout of layout of AC ड्राइव सिस्टम. दैट मीन्स द कंप्रेसर वाला लेआउट भी आपको निकालना है. ये हो गई आपकी वाटर पंप पुली. मैं जस्ट आपको रफ आइडिया दे रहा हूं. ये हो गई इंजन क्रैंकशाफ्ट पुली. तो सर यहाँ से ये बेल्ट यहाँ आ गया. देन बाद में ये जो है ये आपका कंप्रेसर पुली है. तो सर ये आपको लेआउट भी निकालना है अगर आपके पास व्हीकल अवेलेबल है. तो जस्ट दिस इज compressor pulley, this is water pump pulley, this is crankshaft pulley. So just calculate कि ये डिस्टेंस कितना दिया हुआ है. ये सेंटर डिस्टेंस आपका कितना दिया हुआ है, ये डिस्टेंस कितना दिया हुआ है, टोटल बेल्ट का लेंथ कितना लगेगा. So all these things you can draw from this. So sir, this is just expected from you. That means you will do the study of your particular selected model if this is available, and then you can do the calculation of the heat load. तो सर ये हीट लोड का आप एक्चुअली कैलकुलेशन कर सकते हो. कंप्रेसर का मैं इसलिए नहीं बता रहा हूं कि ठीक है, जिनको पॉसिबल है दे कैन डू इट. आई विल शेयर द पेपर्स विथ यू these papers will give you certain correlationship and ideas regarding the calculation. There are some complicated parts, complicated equations given in that paper. If you understand it, it's okay. If you don't understand, leave it. So there is no need, because we need to know the total idea. We are not going to design it for the actual vehicle, but there are so many factors in that, so we need to consider it. Okay. So is there any difficulty, sir, for you? So whatever we have discussed. सर किसी को कुछ डिफिकल्टी है क्या? ये आप इतना अपने व्हीकल के लिए कर पाओगे क्या? आपको क्या करना है सर, बेसिकली मैं आपको पेपर दूंगा, उसमें से इसका ये ओवरऑल हीट ट्रांसफर कोएफिशिएंट का वैल्यू निकालना है। एरिया जो है वो आपको मेजर करना है कि फ्रंट ग्लास का कितना ओपनिंग है, विंडोज का कितना ओपनिंग है, बैक विंडो का कितना ओपनिंग है. So this you have to do it. Then you need to find out what is the heat generated due to the passenger. This you can already find. This you can easily find out. You just have to multiply this by number of the persons who are sitting, and they emit this much amount of energy in 1 hour. Then heat liberated from the equipment, this you can neglect. Then heat received, infiltrated air. For this, you need to assume the temperature inside the vehicle, which is you can use it at 22 degrees centigrade and outside temperature as 45 degrees centigrade. Then because then the AC will be effective, and based on this you can calculate the heat load which is going to be there in the vehicle, and just try to assume this value that from this temperature to this temperature you have to go. You need to assume that the refrigerant is R134 132A शायद, हाँ 132A वो रेफ्रिजरेंट लेके आपको काम करना है. तो सर मैं आपको पेपर्स बता देता हूं कि कौन सा पेपर आपको रेफर करना है. सर यहां तक के क्लियर हो गया? इज दिस क्लियर टू यू? प्लीज कमेंट yes, no, whatever you have difficulty, please. Hello, anybody is there who is awake? Aditya, Atharva. Sir, are you there or sleeping, sir? Anshuman, okay. So I will share the papers with you. Just will show you the papers. ये मैं सर आपको अपने ग्रुप पे शेयर कर दूंगा सर. So this is vehicle AC load calculation. Sir, this is the essay paper which gives you a simple method to calculate vehicle heat load. This is old paper, but this is actually published in SAE International. So he has given you the roof, floor and wall general method for calculation. Then some equations, values of Nusselt number, glass and windshield, how to calculate. Then certain factor, he has given you certain values of the areas that how you can do it. Then fresh air infiltration, whatever we have discussed. Then utilities and occupant, here he has given the proper unit. Then calculation procedure, in Excel spreadsheet you can do these calculations. So these things they are given, and result discussion. So he has shared you the heat load, how he has calculated. So you can use this. सर आपको दिखा क्या सर, ये इसने क्या क्या शेयर किया है? तो ये सर आप देख सकते हो. तो ये इसका यूज करके देन यू कैन do certain calculations. I know that this practical is going to be long one because you have to study, but this is supposed to be the last practical, because the next practical we will be actually doing it. I will show you the cut section of the Scorpio in our lab. So somehow you have to do this kinds of calculation. You need to, I will share this paper with you. That is one paper. The other paper is of similar nature. Here it is the other paper which gives you the, this is written by Indian author, but okay, it will give you an idea because they have also copied from some paper here. they have given the values, cooling load, major sources of cooling load on automobiles, that how much wattage or kilowatt per second, speed range, then life, air distribution. They have shared, I think, some relationship. Then metabolic rate, that is okay, hot day, and DBT and RH, they have given it. Then for calculation, they have given certain calculations. You can see crack length method, air change method. So they have discussed that, and finally they have shown the calculation also. So there are calculations which are given by these people. So this can be the good, you can say, input for you to calculate. So they have given the calculation as well. तो सर आप ये भी कर सकते हो कि उन्होंने क्या क्या वैल्यूज दिया हुआ है, तो इसके हिसाब से आप भी कैलकुलेट करके देख सकते हो. वेंटिलेशन एरिया पर पर्सन, वेंटिलेशन सीएमएम, क्यूबिक मीटर क्यूब पर मिनट फॉर 10 पर्सन. देन दीज आर द इंजन कितना लिया हुआ है. दे हैव शोन स्पेसिफिकेशन ऑफ टोयोटा क्वालिस के लिए उन्होंने लोड एस्टिमेट किया है. दिस इज द सेम इक्वेशन विच वी डिस्कस. So the values are given, overall heat transfer coefficient, how to get it. There are certain relationship with the velocity as well. I will share you this paper as well. तो सर ये जो आपके एक मैंने ये दो पेपर बताए, ये और एक पेपर है एसी लोड पार्ट कैलकुलेशन. एक मिनट, ये पार्ट 1 वाला पेपर है शायद. ये सिंपल मेथड वाले बात कर ली हमने. ये हाँ पार्ट 1 वाला. तो सर ये भी ऐसे ही पेपर ही है. तो ऐसे ही टेक्निकल पेपर का यूज करके ऑटोमोबाइल पैसेंजर कंपार्टमेंट थर्मल कंफर्ट मॉडल 1. तो सर इसमें ना कुछ कुछ आपको रिलेशनशिप दिए हुए हैं. सो यू कैन यूज दैट. ये जैसे ये अ सरफेस कन्वेक्टिव हीट ट्रांसफर कोएफिशिएंट इज thus calculated by the following equation. So please pay attention. Here he has given you the equation. This V is the vehicle speed. So with this vehicle speed, how the heat transfer coefficient varies, you can easily find out. V is either the wind speed or the vehicle standing, or the vehicle speed of the vehicle moving in meters per second. So depending upon this, the value of HE can be calculated. So he has given you. Then this is the sky temperature TS is calculated by the following relationship. ये भी निकाल सकते हो. तो सर इन लोगों ने ना आपको बहुत सारे ये दिए हुए हैं कोरिलेशन. So I'll share this paper with you as well. So here he has shown one diagram as well. So relationships are also given. So please use that. The surface heat transfer coefficient H is equals to this, volume flow and other things they are given. So you can easily calculate. So this is another paper. So I will share you all the 4 papers which are downloaded and which gives you the idea. So mobile passenger compartment thermal comfort model part 2. Though these are old papers, but they give you the basic idea for calculation. So here predicted mean value, whatever is of your use that. Otherwise forget it. So is this clear, sir? सर आप कर पाएंगे क्या ये कैलकुलेशंस हीट लोड का? आप जस्ट कंप्रेसर का पावर तो निकाल के देखिए कि कितना आता है. तो यस और नो सर? Sir, for H4, H3, H2, H1, are we required to assume some temperature values of refrigerant? Sir, definitely. Definitely. See, Pradyumna, आप जितना कर सकते हो, whatever maximum you can do it, you can by referring those papers and this, because as such there is no, as I told you that no formulas are available for designing of the AC system. We should have the idea. See, you refer to any paper, they have done the same kind of calculations. you refer to any paper, this we have seen, then heat generated due to passenger, heat liberated from equipment, heat received from infiltrated air. So all these things are heat due to fan which is operated. So all these heads will be same, only then for specific head somebody has developed the relationship based on the statistical analysis or based on the experiments. So those things you need to use to your advantage. Okay, any other question? Any other question, sir? So if you do not have any question, then we will stop here. Next time we will meet in our lab. Then in next practical session, I will show you the cut section of the Scorpio, which we have recently purchased, and it is available. But at the I cannot show that thing to all the 60 students at a time because there is no space. So we will divide it in batches and then can show you so that everyone will able to have the feeling of what exactly is how the systems they were in the vehicle. Okay, so over from my side, if you have any query, please do ask. If you do not have any query, you may leave the meeting. And one more thing, one more thing, please wait. You have to write down all the experiments because the next experiment is the last one. So I will ask you to submit the journal hard copies in my lab. Okay, so please be ready. By next practical, I will give you one date. That means after that, let us say Friday को practical आता है. So Saturday, Sunday मैं आपको Monday का तारीख दूंगा जिस दिन आपको पूरे आपका जर्नल सबमिट करना है. Every student is supposed to write down the experiments in his own handwriting, all the experiments, and will have to submit the hard copy in the lab because by that time everybody must have been arrived at the campus, so there will be no soft copy submission, there will be hard copy submission by everyone, handwritten thing. Okay, whatever excel sheets you have done for the practical, that will be accepted xerox, but rest of the things have to be written by your own hand, theory and other things. Okay, so thank you. I will ask the group wise submission. So now everything is given to you. Please try to do your best. Thank you. Thank you. Over from my side.